Welcome to the latest Acuity update. It is 18th of February. I am Jonathan Brown, founder of the Acuity fully decentralized social media platform built on Polkadot. And today I'm just going to give you a little update on some of the progress on building the atomic swap exchange for Acuity. So if you're not already aware, we're building an atomic swap exchange, so that will enable decentralized trade between Acuity and the Ethereum blockchain. And also, I think we're also going to add Ethereum Classic as well, because it's very easy to deploy the same technology, and also Ethereum Classic has much lower fees than Ethereum. So in the last couple of videos, you'll have seen that we have this smart contract system written in Solidity. So that's the main smart contract language for Ethereum. And the idea is that there are two smart contracts. We have the sell smart contract and the buy smart contract. And both of these smart contracts are deployed onto every blockchain that is participating in the system. So we would have both on Ethereum and the Acuity blockchain, and also on the Ethereum Classic blockchain, we will have both of these smart contracts deployed. And I've already written a lot of unit tests for these smart contracts, as you've seen from my previous videos. And today I'm just going to show you some more of the unit tests that I've written. So we're using the dApp testing framework, which is a great framework for testing Solidity smart contracts. So I can very easily I can run our testing script, and then it runs all our unit tests that are written in Solidity, so we can see that everything is working correctly. So what I've added today is I've added some more tests to test for the failure conditions. So here we are in the sell atomic swap smart contract. So you can the seller can create their order, and then in response to a buyer on the other blockchain creating their matching order, then the seller then has to lock up some of the funds from the order with the hashed secret provided by the buyer. And of course, one very important check is to make sure that the seller is not attempting to lock up more funds than was originally in the order. So of course, we have a very simple require statement. So we just make sure that it's the amount that's already in the sell order is greater than or equal to the value that the seller is attempting to lock up. Otherwise, we throw an exception with this exception reason, sell order not big enough. So to test this in the dApp testing system, we already have this function to test the actual lock sell method itself. But we add this test fail method. So when you have test fail, this means that in order for this test to pass, it has to throw an exception. So we have test fail, and then I just give it the name lock sell not big enough. And we create the order, and then we lock up some of that order. But of course, we're attempting to lock up more than is in the order. So we have the value is 50. The order is selling 50 of whatever it may be, Acuity, Ethereum, at a price of 5. And then we attempt to lock up part of that order with the same price coming from the same user, so that means it's the same order ID. This is the hashed secret provided by the buyer. We provide a timestamp in the future, and then we're attempting to lock up the value of the order plus 10. So of course that's not possible. You shouldn't be able to lock up more funds than are originally in the order. So of course this will throw the exception, and this test will pass. And what I always do is I write a corresponding control function. So this, I just replaced the word fail with the word control. This doesn't mean anything specific in the DApp testing framework, so this test has to pass. And it's exactly the same as the fail method, except that I'm locking up the exact same amount of cryptocurrency that is in order. So this will succeed, this will fail, and the only difference is this plus 10. So we know that that is the reason that is causing the transaction to fail. It's not it's not some other random problem that could be causing the exception. So in this cell smart contract, so we have this requirement for locking up the funds from the cell order, and then we have some other checks as well. So when you're unlocking the cell as the buyer, you have to make sure that the cell lock has not timed out. If the cell lock has timed out, then the seller has the option to then come in later and retrieve their funds. So of course the cell lock must have timed out by that time. And we do a little check based on the user that's calling this function and the price. So we just make sure that it is the correct order ID to correspond to the hashed secret. So this is just a really great way to test for all of the failure conditions and to make sure that we are actually testing the correct failure condition. So we can see for test timeout cell, so we test fail timeout cell wrong order ID, and we test fail timeout cell not timed out. And each of these have a control function, but I think these are actually the exact same control function. But to test the wrong order ID, so we just change the price. We -1 from the selling price, so that will mean it's a different order ID. And then to test this exception for the timeout, then we just specify a timeout that is in the future. And so of course it's not possible to call the timeout cell transaction for a cell lock that is still in the future. So one of the disadvantages of the DApp testing framework, as far as I'm aware, all of these methods, they're all executed in the same block with the same timestamp. So there isn't really any way to test what should happen with the progression of time with the blocks. There's no way for the block timestamp to change in this testing framework as far as I'm aware. So you just have to kind of work around that a little bit. But that's generally possible, so you can still create good unit tests. And then for the buy smart contract, so that's on the other side of the transaction. It's a much smaller, simpler smart contract. So you just have you can lock up funds to match a sell order. You can unlock the buy, or you can time out the buy if the seller hasn't performed their side of the bargain. And so we have the same situation where we just we have some little tests to just check that the various exceptions are being handled correctly. So we have test fail unlock by timed out, and test control unlock by timed out. And then for calling the timeout by function, we also check that if it is not timed out, we threw the exception, and we also have the control test just to make sure we are only testing this little change here. So that's just a little update on how things are progressing for the Acuity Atomic Swap Exchange. I'll leave it there for today, and I'll have another video for you very soon. Don't forget to join our Telegram channel, link below. Thanks.